There was an error in the preceding where I had the 1 over a here that came from the integration of the natural log of 1 plus, well, the reciprocal of 1 plus AV. We had the 1 over a here, but it didn't get written down here, and I went ahead and proceeded from this expression, and that was incorrect. So what I wrote down for the integral on the left-hand side should be 1 over 2a, and a was the square root of c over f, times the natural log of 1 plus square root of c over f times v divided by 1 minus the square root of c over f times v. And that was equal to the antiderivative of our right-hand side, which would have been f over mt plus c1. Previously I also wrote this as c, which would make it look like it was the same as this c, and that's not the case. Now if I multiply both sides by 2 square root of c over f, we're going to get natural log of the absolute value of this expression. I'm not going to write that expression down in this step. But we're going to get 2 times what? F divided by the square root of f. Well, that's going to be 2 times the square root of f. And then we got the square root of c, so we're going to have the square root of c over m multiplied by t plus c1. And that simplifies. We can write that simply as 2 times the square root of fc over m multiplied by t plus an integration constant. So again, we have the natural log of the absolute value, and I'll write that out this time, 1 plus the square root of c over f times v divided by 1 minus the square root of c over f times v. So this is a correct integration of this original left-hand side, and then a correct simplification on the right-hand side. And we're going to proceed then to solve this for v. Now let's notice 2 things. One is that f can't be negative, so you can't have a negative force. There can be negative forces, but this solution only applies if the force F is positive. In that case, then, as long as the square root of c over f times v is less than 1, this expression is going to be positive, and the natural log of the absolute value is just going to be the natural log of this quantity. So that when we raise e to this side and raise e to this side, what we get is it is not going to involve the absolute value signs. And in fact, let's go ahead and do that. First we get absolute value of 1 plus the square root of c over f times v divided by 1 minus the square root of c over f times v equals e raised to the 2 square root of fc over m multiplied by t, and then that'll be times e to the c1. We're going to replace e to the c1 by a constant a greater than 0, and we've seen why that's the case. And we can say that if this term is positive, this term of course always will be positive, provided the denominator is also positive, we can write this as 1 plus the square root of c over f v divided by 1 minus the square root of c over f v equals a e to the 2 square root of fc over m multiplied by t. And the condition is that square root of c over f times v remains less than 1.